Hi everyone. In this video, we're going to talk about Lab 3 and investigate op amps. Okay, so in Lab 3, we're going to need a positive and negative 15 volts that run along the circuit type 2 circuit strip on this side, on the left side here. So it's going to be, so the way we connect the DC-DC converter, the wiring is going to be different than what we had in the lab 1s and 2. So here, we're going to connect so we're going to use this figure here, figure 5 here, in order to create the positive and negative 15 volts on this side. All right, so first pin 1 connected to row 1, like so, in the way that it's depicted here. And so you'll see that the right type 2 socket is going to be connected to the battery, same as before, which is going to be 5 volts, right? Now let's connect the positive side of the battery here to pin 1, okay? This yellow wire, as you see here. So the yellow wire, positive side to pin 1. So positive to pin 1. Okay, and then connect the negative of the battery to pin 2, which is connected to row 2, like so. And okay, and also now let's go to the output. So we have to connect pin 6 here. So pin 6 is this one. As you can see, pin 6 gets connected to the positive 15 volts, which is the positive side here. Pin 6 on row 6 to the positive. And then the black wire, I connect row 4, which is here, to the negative terminal, as you can see on this graph here as well. Right, okay. So one more thing is that I need to connect my pin 5, which is on row 5. So 1, 2, 3, 4, 5. So this green to the negative terminal of the battery as well. So like this. So all these green connections are connected to each other. Okay. And this way we'll be able to, if we give 5 volts here, we'll get a positive and negative 5 volts with reference to this negative terminal, which is the ground here, because we made this negative terminal ground. Okay, so let's create the 5 volts. Same as before, we're going to use the battery holder. Okay. Okay, flip it so that you have the on-off switch at the top. So make sure it's off and then connect it. Next, we're going to bring the multimeter. Okay, and we want to measure. Okay, let's first measure the input. So the input should be 5 volts, right? So put this to 20 volts. And okay, so we get the 5 volts. Now, if I have my reference connected to the negative terminal of 5, and if I connect it to the positive terminal here, I should see 15 volts, right? Yeah, positive 16 volts with that error. And if I connect it to my negative terminal, I want to see negative 16 volts, which is what I see here. So good. So my circuit is now set up correctly. Also, if you look at the voltage across this, it should be 32 volts, right? The actual socket 2. So because we're limited to 20, we have to go to 200, and you'll see that you'll have 30 volts. So this positive and negative 16 volts is with respect to this negative rail here, which is connected to the battery, right? So positive 16 and negative 16. Okay. Okay, so let's turn this off. And okay, now let's go ahead with the lab. And the first one is the non-inverting amplifier, which is depicted in your figure 2 here. So for that, we're gonna need an op amp. You can find it in this in here. So you're given 5 op amps. Okay, so if you look to this, you're gonna see a circle here. So this determines, this dot here determines where pin 1 starts. So pin 1 starts right next to this circle. So this is going to be pin 1, right? And let's go to figure 6 here. So as you can see, pin 1, 2, 3, 4 goes down. So from 1, 2, 3, 4, and then 5 starts from the bottom to the other side. So 1, 2, 3, 4, and then 5 here, 6, 7, 8 comes up. Right, 1, 2, 3, 4, 5, 6, 7. So you only have to determine where pin number 1 is, and you can do that by seeing this, looking at this dot here. Okay. So how do we connect it to our breadboard? You always have to make sure that this separator here, your IC uses this separator here. So 4 of these legs, so pins 1, 2, 3, and 4 are connected to column E, right? So this is column E here. You can see the column name here. So column E. And the 4 pins 5, 6, 7, and 8 are connected to column F. So this separator is in between here. So it's going to be wrong if you connect it like this, for example, because in this way, pins 1 and 8 would be connected to each other, all right? And we don't want that. So make sure to have this separator in between. So 4 legs connected to column E, and then 4 legs connected to column F here. Okay, now we're going to connect the power supplies of the positive and negative 15 volts to the op amp. And for that, we're gonna connect the positive VCC, which is pin 7, 1, 2, 3, 4, and then 5 starts from the bottom, 6, 7, to, I'll use a red wire, to the positive 15 volts, and then connect the minus VEE pin 4 here to the negative 15 volts. Okay, and yeah, so now let's go and create our figure. So this is our non-inverting amplifier from this figure. So this is the graph. So RF and RS are 1 kilo ohm and 2.2 kilo ohms. So this is RF, 1 kilo ohm. It's connected to the output pin, which is pin 6. Pin 6 is this one right here, and pin 2. So you can connect it like this. Make sure to connect it to the right holes. And then RS, which is the 2.2 kilo ohms, is connected to pin 2 and the ground. The ground is a bit too far, so I'm going to connect it to another pin here. And then from that, I'm going to use a green wire to connect the ground to the other end of RS. So other end of RS is here, and the ground is connected to the negative terminal of the battery. Okay, it's not connected to the positive terminal of, it's not connected to the negative terminal here. and this negative terminal is minus 15 volts, and this negative terminal is ground. So the ground is here. We're going to connect the ground to this point. And next, we're going to connect V in, and which the question tells us to be positive 5 volts to pin 3. So this positive 5 volts, we had it here, and we're going to connect it to pin 3, which is here. Okay. So now we are ready to make the measurements. So first we want to see the output voltage with reference to ground. I want to see the voltage here, okay, with reference to ground. So my black probe, I have to connect my black probe to the negative terminal, to the ground here, which is negative terminal of the battery. Again, not negative terminal of this side. The negative terminal of this side is minus 15 volts. And then connect this to the output, which is pin 6. Right, now let's turn this on, and you'll see that we have a voltage, and compare this voltage with what you found in your pre-lab and explain. Next, I think we have to connect a 1 kilo ohm resistor. So turn this off whenever you want to work with your circuit, turn it off. Let's see what the lab says. So connect a 1 kilo ohm resistor across V out. So we connect, take this out, a 1 kilo ohm resistance here, and then to the ground. Right, so I connect this 1 kilo ohm resistance. Again, I repeat the measurements. Do I see any difference or do I not see any difference? And then you have to explain why or why not. Okay, so like so. Okay, so make sure to go through the actual process and read and answer every question. And okay, so next we're going to go to part 2, which is the inverting summing amplifier. Okay, so for part 2, we want to create the inverting summing circuit here. So we have the op amp, and first thing we do is that we connect its power supplies. VCC, which is pin 7, should be connected to the positive 15 volts, and minus VEE, which is pin 4, is connected to the negative 15 volts. Okay, so now let's construct this circuit. We'll see that pin 3 is connected to the ground. Again, the ground is connected to this negative terminal of the battery. It's not this negative terminal here. This one here is minus 15. These green ones are the ground. And okay, so now we have to connect RF, R1, and R2. All right, so RF is 100 kilo ohms, and it is connected between pins 6 and 2, which are the output pins, and the inverting pins. So I'll carefully connect these resistors, and then R1 is again 100 kilo ohms, which is connected, one end is connected to pin 2, and then the other end is connected to V1. So I'm just going to connect the other end here for now, and then connect V1. With V1 is given to be plus 15 volts. So I'm going to connect this plus 15 volts from here to the other end of my resistor. Okay, so that's it for that. And now for R2, which is given as 51K, you connect it to pin 2, and the other end you connect to some other point where you want to later on connect V2. But for the first part, we don't want to connect V2 to anything. We just want to measure the output of this circuit here when we turn this on. So put your multimeter so that it measures DC voltage, and then the black probe, as always, goes to the ground, and the red probe goes to the output, and we have minus 14.6 volts here. Okay, so let's turn this off and work on the circuit. Now we want to add some DC offset to the circuit. How do we do that? We do that with this potentiometer here. So this is basically a variable resistor. And what I'm going to do is that I'm going to connect a positive 15 volt here, as shown in this picture. So look at this. So positive 15 volts to the top, positive and negative 15 volts to the bottom, and then the midpoint will be connected to the resistor R2. So this midpoint will create my voltage V2 for me. And as I change the resistance, as this pin goes up and down, so I can change the voltage of V2 that is going to my R2. Okay, so the top one is connected to the positive 15 volts. I'm going to connect it with the red wire, and the bottom one, which I'm going to connect with the black wire, is connected to the negative 15 volts. And the middle point is going to go to the R2. So here R2. Okay, so by changing this, I'm going to change the voltage V2 and give different DC offsets to my output. So let's go ahead and measure my output. So the black terminal, as always, is connected to the ground, and the red terminal is connected to the output. So let's connect this back in. And okay, so at one end, you'll see that this is positive 15 volts, and as I change this resistance, you'll see that this value starts to drop. So, and that's because the voltage here, V2, which is this yellow wire, changes as I am changing this dial here, and it gives this different DC offsets for my circuit. As you can see, it just went down, and it's going to negative right now, and it'll go down to minus 15 volts, minus 14.38 here, and stay there. Okay, so this is how you connect the DC offset. So now you have to explain how this, when you're changing this, what we explained here basically. How is it affecting the output as you are changing this dial? Okay. Okay, next. So let's turn this off. Let's turn the battery holder off. Take this out for now so that we can work on the circuit. Now we want to add a comparator. So this is a comparator, and as you can see, so we need another op-amp in order to create this comparator. And take this and put this up here. So remember, the separator should be in between here. Okay, and oops. So first of all, first I need to connect the power supplies. So pin 7 connects to positive 15 volts, and pin 4 here, minus VEE, connects to minus 15 volts. Okay, and okay, so now I connect pin 3 to ground. Ground again are these green wires. So all the green wires and all the red wires are connected to each other in this graph here, in this picture here. And okay, so as you can see, what's going to happen right now, if pin 2, I want to connect my pin 2 of this to the V out of this op amp here. And if my pin 2 is less than pin 3, that means my output is going to be positive 15 volts, right? If my pin 2 is less than pin 3, it's going to be positive 15 volts. But if my pin 2 is going to be more than the value of pin 3, it's going to be negative 15 volts. And what's the value of pin 3? It's 0 because it's connected to the reference. So if I have a negative voltage at pin 2 or my V out, then my output voltage is going to be positive 15 volts. And if I have a positive voltage in my V out, then my output voltage, basically pin 6 here, would be negative 15 volts. And then I want to connect this to a 1 kilo ohm resistor and the output and an LED. And you can find the LED in your lab kit here. An LED is a light emitting diode, and it can only conduct current in one direction. Okay, so if you can see here, from anode, it can conduct from anode to cathode. So the anode is the longer one, and we're gonna connect it to the we're gonna connect anode to R1 and the cathode to ground. So ground is gonna be this one right here. Okay. So here, when my output is positive, then my LED should turn on. And when my output is negative, then my LED should turn off because it only allows current to flow in one direction. And okay, so when is this positive? When my pin 2, the pin 2 or V out is negative, has a negative voltage. So when V out has a negative voltage, then my LED should turn on, and my V out, when my V out is a positive voltage, then my LED should turn off. Now let's test to see if that happens or not. Okay, so I'll connect the battery holder. Okay, and let's use a white wire to connect the output pin from this op amp down here to pin 2, as you see in the schematic here. So we connect it using this white wire, and so now let's set to measure the V out. So I'll put this to DC voltage, and then I'll connect the black to the ground and the red to V out. And okay, so let's turn this on and then play with this potentiometer to get different output voltages and see how the LED reacts to it. Okay, so first, the output voltage seems to be positive 15 volts. And when we have a positive at the output, and so what's going to happen, that there's going to be a comparison. So this, since this is higher, there's going to be a negative 15 volts, so the LED won't turn on, right, as we expected. So let's see what happens as we change the potentiometer slowly and this voltage starts to drop. And what happens if we go to negative? So you see, once we go to negative, the LED starts to light and conduct. So as you can see, and it will conduct when the voltage is negative. And this is because when your V out becomes negative, then because of this comparator, your output voltage V6 here, the pin 6 here, would become positive, and then your LED would conduct. So there's a transition point in between here. So what's that transition point? It's very close to, as you can see, that transition point between turning on and turning off. So slowly adjusting the potentiometer. See, it's right on zero, about zero, right? Okay. Yeah, so it's about zero that it starts to dim down. Okay, and so we want to find what the voltage of V2, if you remember, the voltage of V2 was going to the R2. So I'm going to take the red wire out and then voltage, make the measurements of this yellow wire here and see what that voltage is. So record this voltage and then explain why this voltage is the transition point of the LED where it turns on and off. And it's just basically what I explained here. It gives you the 0 points, but just say why this voltage gives you the output 0 volts, and then how that changes the comparator, and then the output voltage of the comparator, what you understand from this, basically. And then this voltage here will be compared to a simulation that we're going to do later on in this lab. Okay, next, we're going to go to simulation, but before that, let's turn this off, take this out, turn the multimeter off, and make sure to take these batteries out of the battery holder. This is important. And yeah. Okay, so now we're going to create the inverting summing amplifier in Simulink. So from the MATLAB page, go to Simulink, same as before, create a blank model. And then first thing, we save our model, hit save, and then go just save it somewhere. I'll save it as lab3, or you can save it as lab3 and then save it. Okay, so now we're gonna have to bring our components in for the inverting summing amplifier from the library browser. So first thing, I'll go to Simscape, and then in electrical, under electrical, first I need voltage source from the sources. Okay, so I'll need 2 voltage sources. I'll bring one, and then I can copy and paste to make the other voltage source. I also need resistors. I can find it from the passive section, resistors, add to model. Then I'll need an electrical reference from the connectors and reference. I'll also need sensors, voltage sensors, which I can add from here. I think that's it from here. And we're also going to need a, so from the integrated circuit under electrical, you can find the finite gain op amp. And so you add that as well. Okay, so yeah, we're done with the electrical part. We go to utilities as always. We have to add the solver configuration, and we need the PS to Simulink converter. Okay, close Simscape, then go to Simulink, and under Simulink, go to Sync and add a scope. Okay, so that's it. I think for our elements, let's take these away so that we can see what we have. Okay, so let's create our inverting summing amplifier. So I'll copy and paste this. I'll need a resistor for R1. This is going to be the op amp. I want so as you can see, the positive terminal is up, so I want the positive terminal to be on the bottom side. So I can flip it using Control I, and then Control R to rotate it. So I have the negative, the inverting terminal at the up right now. So this is R1, and then Control C, Control V for R2. And this is my V2, and this is the ground. Let's connect these up. Okay, so I'll also need the ground connected to the non-inverting pin, and Control C, Control V for RF at the resistor here. And okay, FX, the solver configuration, we want to add it to we want to connect it to the ground here. Okay, and so we need two voltage sources. We want to so this is voltage source V1 and this is voltage source V2. And so we want to, so Command I to flip it, and I want to make the measurements across V2 and V out. So Control C, Control V. Okay, so I want both of these waveforms, V2 and V out, to go into the same scope, and I want to see it on the same graph. So I can do this by right-clicking on the scope and then going to Signals and Ports, and the number of input ports. I can change it to 2. Can expand this, and then I can bring the signals from here into these 2 ports. But I'll also need 2 PS to Simulink converters. So Control C, Control V to create another one, and then I'll bring these 2 signals inside the scope. Okay, and yeah. Okay, so now let's put in the values for the voltage sources and everything else. VX is given to be 15 volts, and then R1 is 100K. So here is ohms, so we have to change it to kilo ohms, and this is 100. So RF is also 100K. Change this to kilo ohms, and this is 100. And R2, this one down here, is 51 kilo ohms. So the same way that you had in the actual experiment. But in the actual experiment, for this V2, if you recall, we just put in a potentiometer, and then we gave the middle point of the potentiometer to this side. So instead of that, right now we're just providing a separate voltage source here. And for the beginning, we're just going to give it a voltage source of 15 volts and see how it works in the output. But there's one other thing that we need to change, and that is the properties of this op-amp. So change the gain to 200,000, and so the input resistance is 2 mega ohms. The output resistance, change it to 0, and then minimum output is minus 15 volts, and then maximum output is plus 15 volts. Okay, I think that's it. So we can just save our simulation and run it. Okay, so let's open the scope up. Okay. Oh, okay, so I forgot to name it. Okay, so we can name this signal by double clicking on this arrow here, and then, so this was V out, right? So I'll write V out here, and then I'll double click on this arrow here, and then I'll write V2, and then run the simulation again. Then double click. Okay, so you see that here V out is the yellow line, or here, and V out is
So V out is the yellow one, and V2 is the blue line here. So V2, if you recall, was this voltage here, which in our experiment was provided by our potentiometer. So the midpoint of that potentiometer was basically V2. So if V2 is 15 volts, we'll see that our V out is from the statistics, the mean is equal to the DC and is equal to minus 15 volts, right? As you can see here. So what happens if I change this to from 15 to minus 15, the voltage of V2? Okay, so what will I see? So let's run this. So V2 is minus 15 volts, but you'll see that my V out now is positive 14.4 volts. So it went to positive. So there's a transition point in between where the mean of V out will be 0. And you guys have to play with this voltage of V2 to give this different DC offset to it to find what that voltage is, where V out, which is here, the mean of this, becomes 0 or near 0, somewhat near to 0. So let's give minus 7.7 volts here as V2 and run this again. So you'll see that the mean value here becomes really small, right? And so it's about 0. And so the DC offset that's required to make this output 0 is about minus 7.7 volts. And you'll notice that this value is kind of very close to what you found as the voltage measurement in your lab experiment. So you just have to explain why the similarities between these voltages of V2 being minus 7.7 volts here and the voltage that you measured at your experiment. So that the voltage that you measured was the transition point where the LED was turning on and off, and the V2, if you recall, was about this voltage as well. So you just have to explain why the similarities between this. That similarity is between this simulation and that experiment. And that's it for the lab. Thank you very much, everyone.